Good morning. Mr. Herman is back again with some two variable statistics notes. So we're going to take a look at not one variable like we did before. Now we're going to take a look at two variables. Okay, so now we're in the coordinate plane. We got an x and a y-axis like we've seen before. And we're trying to see relationships between two variables. All right, so we're going to go ahead and talk about regression lines. You might have seen regression lines before, but what a regression line is it's a line used to model a trend. Okay, now a trend, we might also think of that as a pattern. Okay, I'm going to put that in parentheses down here, a pattern that we see in a scatter plot. Okay, so how can we draw a regression line? We'll see in the calculator later on, good way to how we can make a regression line. But for now, if we're just sketching a regression line, we're going to draw a line that is closest to all the points. Okay, now this might seem a bit weird because it's like, how can we be closest to all the points? I get that, okay? What we're trying to do is we're trying to make sure that this line does the best job of kind of going through some of the dots, have a few dots above the line, have a few dots below the line. Okay, so that's part of what we're going to be doing in our assessments this week. Is we're going to be sketching regression lines. So Mr. Herman's going to do a little sketch right here. Okay, let's see how we go. Okay, it's not a terrible regression line. Looks pretty close. Notice how it goes through a couple of data points. Okay, but we've got 3 points that we see below the line. We got maybe 1, 2, 3, 4, 5 or so above the line. So that might be not the best regression line, but when we're sketching a regression line, what we want to do is kind of capture the same number of points above the line and below the line. So basically, we want to show the trend that's going on. As we can see, this trend is going up to the right, and my line goes up to the right as well. Okay, so what we're going to do is we're going to estimate the slope and the y-intercept. Okay, so let's go ahead and remind ourselves what the slope is of a line. Okay, so for slope, we're going to do a little slope triangle action here. So we want to do I'm going to find 2 points on this line. There's a point right there. Here's a point right here. So this change in x and this change in y. Let's see. It looks like we're going up about maybe 4. And we're going right 10. Okay, so change in y. So my estimate for slope is 4 over 10, which is 0.4. Okay, notice how we estimated. So there's my slope. Okay, now my y-intercept, we'll remind ourselves what y-intercept is. It is where it crosses that y-axis here. And that looks like maybe -4. Okay, so notice how these are just estimates. If you think that it's a little bit different, if your regression line is a little bit different, that's cool, that's fine. But we do want to make sure that based off the regression line that you draw, you're estimating that slope and y-intercept. As long as they're close enough, we're good to go. All right, now we're going to remind ourselves the equation of a line. So hopefully we said y equals mx plus b, and we got some plug or redo action going on here. So our slope we said is 0.4, and so we're going to have x here. And then b we said is -4. Oh, I should have just said minus. I'll do plus -4. Okay. You could also put y equals 0.4x minus 4. Either is fine. So now, we're going to go ahead and interpret our slope and y-intercept in context. So whenever we do a regression line, we always are doing modeling, so there's a context going on. We got to do that interpretation piece. So slope, we're going to see, okay, so first off, what is our context? We're doing points per game and wins of SEC football teams in 2011. Okay, so if we're interpreting the slope, our x values are points and our y values are games. Okay, so we can say the slope, actually wait, let Mr. Herman do some color coding here. The slope, so we can say for each additional point per game, that's my X value, the wins go up by 0.4. Okay, and wins is my Y value. Now, let's take a look at our y-intercept. Now remember, at y-intercept, that means that our x value is 0. So that means that if we score 0 points per game, there's my x value, we win -4 games. Okay, and there's my y value. Oh, we're going off the screen. All right, that's my y value. Now, obviously, that y-intercept doesn't make sense. And if you take a higher level statistics course, you'll discuss more about why we need to have that -4 games there, but also why it doesn't make sense. All right, so there's our regression line. Now, we're going to move on to something called an R value. Okay, so what this R value does is going to show how close to a line our scatter plot data is. Okay, so there's a few characteristics of R that we're going to fill in here. First off, R is always between -1 and +1. Okay, if the data is going up to the right, it's going to be a positive R. If the data is going down to the right, R is negative. Okay, now we're going to try to figure out how to determine if it's close to 0 or far away from 0. Okay, so if the data looks very random, the R value is going to be close to 0. Now, on the opposite, if the data looks very, I'll say patterned, the R value is going to be close to 1 or -1. So we're going to take a look at some scatter plots and do some estimations of R values. Once again, these are estimations. Okay, that's the cool thing about statistics is we do a lot of estimating in statistics because oftentimes close enough is good enough. All right, so we look at this scatter plot here. We have a lot of dots that are pretty close to a line. We can tell it's going down to the right, but it is going down. So we got to make sure that we're thinking, okay, R is negative. I'm going to put a negative here. It's pretty close to a line. I'm going to say maybe 0.9. Okay, if it was a perfect line, it would be -1. But since it's not a perfect line, it's pretty close to a line, maybe -0.9. This second scatter plot's going up to the right. It's fairly close to the line, maybe a little bit more scattered than our first one, but it's going to be positive. I'm going to go with maybe 0.85. It's like a pretty good estimate there. Now, we got our data in the third scatter plot here. Now, if I'm looking at this data, it to me says it's going up to the right, but it's not really close to a line. Got a lot of points that seem to be kind of random all over the place. So I'm going to say maybe it's an R value of about 0.5. Okay, so definitely positive, but maybe a little pattern, maybe not. Hard to tell. And then this last one, we got this big mess over here. Okay, got a whole lot of random dots in this scatter plot. It's literally scattered. I don't know what it would be. I'm going to say something real close to 0. I'm going to go with maybe, I think it's positive. I'm going to say 0.1. Okay, so it's real close to 0. It's pretty random. Okay, so let's take a look at interpreting these R values. Okay, so when we're interpreting R values based on if it's positive or negative, and if it's close to 1 or close to -1 or close to 0, we're going to use a couple of things when we interpret. Okay, so if we have this 0.8 to 0.1, we're going to call that a strong positive association. Oh, running out of room. Okay. 0.3 to 0.8, we're going to call that a moderate positive association. -0.3 to 0.3, we're going to say no association. Okay. Or you could say weak. I'll put weak in parentheses, but no association if R value is that low is fine. They're close to 0. Now, negative 0.8 to negative 0.3. Hope you're kind of thinking, okay, moderate, because it's in those values. But since it's negative, we have a moderate negative association. And then negative 1 to negative 0.8, same as before, strong but negative association. Okay, so if we're looking at, let's go and do an estimate and interpret the R value for our scatter plot from earlier. Okay, now we saw our graph. I'll look at our scatter plot real quick. If we're looking at this scatter plot right here, I'm thinking it's pretty close to a line. So I'm thinking maybe 0.9. It's got to be positive. Got to be positive because it's going up to the right. My estimate's going to be R is approximately 0.9. Seems good enough. Now, for interpreting the R value, we know a couple things here. That we can say there is a strong positive association. Now, I have some context here. Always got to include that context between points per game and wins. Okay, so there's a strong positive association. Now, you might be saying, Mr. Herman, of course that makes sense. Okay, if you score more points, you win more games. Well, let's talk about this here with correlation and causation. Okay, what is correlation? Correlation is when we see a relationship or association between two variables. Okay, so we see this association here. It's a strong positive association. We see this association. So these two are correlated, strongly correlated, because it's 0.9 for the R value was our estimate. All right, so there's our first thing. Now, what is causation? I say, well, of course, Mr. Herman, causation means something causes something else. Okay, when something causes an event to happen. I'd be like, right you are. I agree. Now, where we oftentimes get caught up here is that correlation does not imply causation. Okay? Why does correlation not always imply causation? We've got something here is we said, okay, points per game leads to more wins. That makes sense. Okay? But we got to think about in football, you have offense scores points, but also defense can't give up points. Okay? So we have that other variable. Okay, so why does correlation not always imply causation? There may be other variables affecting the relationship. So one of Mr. Herman's favorite examples is that when there are more ice cream cones sold, there are more shark attacks. And you say, Mr. Herman, what's that? I guess that kind of makes sense, because if I'm at the beach, I get ice cream, and then there's more people at the beach, and so there's more shark attacks. That makes sense. Yeah. But do you think that because we're selling more ice cream cones, that there will be more shark attacks? I would say that the variable that is the other variable affecting the relationship is that it's hot outside. And I'm like, oh, it's hot outside. I'm going to go to the beach. I'm going to get an ice cream cone. I'm going to get in the ocean. Okay? And so then that other variable, that heat, that sun, is affecting the relationship. It's not like, oh, we need to stop selling ice cream cones because it's going to decrease shark attacks. The people are still going to go to the beach. They're just going to eat something other than ice cream. Okay, so there's that other variable affecting the relationship. So that's what we got to think about. Okay, that's probably one of the most challenging things to think about in our course. And if you want to think more about that, I encourage you to take a higher level statistics class. Now, if we're thinking about correlation and causation from our scatter plot earlier, relating points to number of wins, I kind of talked about this already. But in football, there's defense. Okay, so I'm going to say maybe there is causation. But what about defense? Okay, So it makes sense that there could be causation here. Because, well, yeah, if you score more points, you win more games. But maybe you don't score many points, but your defense is really good. And so you only score like 14 points a game, but you only give up like 3 points a game. And so you win 10 games in a season, but don't score many points. Okay, so there's that other variable that's impacting the result. Okay, so that's the key thing is whenever you see a relationship, always think to yourself, is there something else that could be here that causes this relationship to happen? Okay, because it's not always going to mean that we have something and then it causes something else. Okay, if you're real interested in how we can identify if there is causation, once again, I encourage you to take a higher level statistics course. I may or may not teach that higher level statistics course. All right, so go ahead and get started on your practice as you work through the assessments this week. Thanks.